building railroad tracks in the early 1900s, a testament to true grit and ingenuity. The early 1900s marked a period of rapid industrialization and expansion in the United States, and the construction of railroad tracks played a crucial role in this transformation. Between 1903 and 1909, the task of building railroad tracks through challenging terrains, such as river bottoms and dense forests, required a combination of emerging technology and sheer human determination. The track crews, often referred to as track gangs, were the unsung heroes of this era, working tirelessly to lay the foundation for the nation's burgeoning transportation network. The track crew, a tough and resilient workforce. The track crews were composed of hardworking men who braved the elements and the rugged landscapes to build and maintain the railroad tracks. These crews were known for their toughness and resilience, as they faced grueling conditions and physically demanding labor. A photograph of a track crew from this period reveals a group of determined individuals, their faces etched with the hardships of their work. These men were responsible for every aspect of track construction, from grading the land to laying the rails. This is Dad Esterling and the track crew for the Crossett Lumber Company, circa 1918, courtesy of Jan Dawson. Found this image in Pictorial Observations of Crossett and Ashley County, 1994, by Ashley News Observer. The process of building railroad tracks. Grading and preparation. The first step in building a railroad track was to prepare the ground. This involved grading the land to create a level surface and ensuring proper drainage to prevent water from accumulating around the tracks. In low-lying areas like river bottoms, large embankments were built to elevate the tracks above potential flood levels. This required hauling and compacting vast amounts of dirt and rocks, often using horse-drawn carts and manual labor. Laying the ballast. Crushed stone, known as ballast, was spread over the graded surface. The ballast provided stability to the tracks, distributed the weight of the trains, and aided in drainage. It also prevented vegetation from growing around the tracks, which could interfere with the rails. Placing the ties. Wooden ties, also known as sleepers, were laid on top of the ballast. These ties were substantial in size and weight, often made from freshly cut green wood. In some cases, the ties were treated on-site to increase their durability. The ties were spaced at regular intervals and served to keep the rails in place. Laying the rails. Steel rails were then laid on top of the ties and secured using spikes or bolts. Workers known as gaugers ensured that the rails were the correct distance apart, gauged, and aligned properly. The rails were joined together using fish plates and bolts to create a continuous track. Aligning and leveling. The track was then aligned and leveled to ensure it was straight and even. This step was crucial for the smooth operation of trains. The ballast was tamped down to ensure it was compact and provided a solid foundation for the tracks. Final inspection and maintenance. Once the track was laid, it underwent a final inspection to ensure it met all safety standards. Regular maintenance was also required to keep the track in good condition and address any issues that arose over time. Emerging technology and tools. While much of the work was done manually, emerging technology played a significant role in making the process more efficient. Steam-powered machinery, such as steam shovels and cranes, was used to move large amounts of earth and rocks. These machines, combined with the labor of the track crews, allowed for the rapid construction of railroad tracks through challenging terrains. The weight of progress. Trains and their impact on the tracks. The trains that ran on these newly constructed tracks were massive and heavy. Logging trains, in particular, hauled immense loads of timber from the forests. A single train could carry around 100,000 board feet of lumber, weighing approximately 350,000 pounds, 175 tons, per trip. With trains making multiple trips per day, the weight exerted on the tracks was substantial. The locomotives used during this period were primarily steam-powered and could weigh up to 65,400 pounds, 32.7 tons. The combined weight of the engine, loaded cars, and the lumber they carried placed immense pressure on the tracks and the spikes that held them in place. The constant wear and tear from the trains passing over the tracks required regular maintenance to ensure their stability and safety. Conclusion. The construction of railroad tracks in the early 1900s was a monumental task that required a combination of emerging technology, manual labor, and sheer determination. The track crews, with their grit and resilience, played a crucial role in building the foundation for the nation's transportation network. The challenges they faced, from grading the land to laying the rails, and the immense weight of the trains that ran on these tracks, are a testament to their hard work and ingenuity. As we look back on this period, we can appreciate the remarkable achievements of these unsung heroes and the lasting impact of their efforts on the development of the United States. Building railroad tracks, over 12,000 spikes per mile. Building railroad tracks is a complex process that involves several key components and steps. This essay will explore the essential elements of track construction, the materials used, and the evolution of labor and technology in the industry. Components of railroad tracks. Ballast. The foundation of the track. Ballast is made up of crushed stone or gravel. It provides stability, drainage, and distributes the load from the trains to the ground. Ties. Sleepers. These are rectangular supports laid perpendicular to the rails. Traditionally made of wood, modern ties are often made of pre-stressed concrete. They hold the rails in place and maintain the correct gauge. On average, there are about 3,249 ties per mile on a wooden tie system. Rails. Steel rails are the main component of the track. They guide the train's wheels and bear the weight of the train. Rails are typically made of high-quality steel to withstand heavy loads and extreme weather conditions. Fasteners. These include spikes, screws, and clips that secure the rails to the ties. They ensure the stability and alignment of the track. On average, there are about 12,800 spikes per mile on a wooden tie system. Construction process. Surveying and grading. The first step in track construction is surveying the land and grading it to create a level surface. This may involve cutting through hills or filling in valleys to maintain a consistent grade. Laying the ballast. A layer of ballast is spread over the graded surface. This provides a stable base for the ties and rails. Placing the ties. Ties are laid on top of the ballast at regular intervals. The spacing of the ties depends on the type of track and the expected load. Installing the rails. Rails are placed on the ties and secured with fasteners. The rails must be aligned precisely to ensure smooth and safe train movements. Ballasting and tamping. Additional ballast is added around the ties and tamped down to secure the track. This process ensures that the track is stable and properly aligned. Final adjustments. The track is inspected and any necessary adjustments are made to ensure it meets safety and performance standards. Evolution of labor and technology. In the early days of railroad construction, much of the work was done by hand. Workers used simple tools to lay the track, and the process was labor-intensive and time-consuming. Over time, mechanized equipment was introduced, revolutionizing the industry. Handcars and motorized carts. Initially, workers used handcars and motorized carts to transport materials along the track. These were later replaced by more advanced machines. Modern equipment. Today, specialized machinery is used to lay and maintain tracks. This includes track-laying machines, ballast regulators, and tamping machines. These machines have significantly increased the speed, accuracy, and safety of track construction. Conclusion. Building railroad tracks is a complex process that involves careful planning, precise execution, and the use of advanced technology. From the initial surveying and grading to the final adjustments, each step is crucial to ensuring the stability and safety of the track. The evolution of labor and technology has transformed the industry, making it possible to build and maintain tracks more efficiently than ever before.